Welcome back, everyone. So, as I said earlier, we're really looking forward to this presentation because we should not only think about what assets we are building, but how we're going to take them apart and how we can do that in a manner that is kind to the environment as well. So, Dr. Heather Phillips, has got some unique experience. Has taken an operating reactor all the way from defueled through to decommissioning, which is quite an achievement and probably a very unique experience in the world, I'd say. I'll pass you over to Heather. Thank you.
Okay, Jazz, thank you for that introduction. Good morning, everyone. So what I'd like to talk about today is really the decommissioning phase of the whole life cycle. How can that rise to the challenge of meeting net zero? We've certainly heard a lot from yesterday's presentations about how important nuclear is going to be in the energy mix moving forward, seeking to reduce our carbon emissions to net zero. But there are other phases to that nuclear life cycle where we're still generating carbon, and what can we do to minimize that? So the first thing I thought I'd look at was what are the current carbon costs to the decommissioning phase, and these are largely linked to transport and to construction and dismantling. So if we look at transport, at the moment we're largely reliant on the fossil fuels, the diesel or electricity that's not necessarily generated in a carbon neutral way. As we've heard, going forward, we're hoping to decarbonise the transport system, and that will have huge benefits in terms of the decommissioning and being able to transport materials and equipment that we're going to need to bring to sites to build new facilities, whether they're waste facilities or new equipment for novel methods of dismantling radioactive materials. We've got a lot of fuel transports to make, so that's certainly at the current stage. Over the next 10 years, as we bring more power stations offline, that's going to be significant transport additions, as well as all the other wastes that are going to be produced, whether they're radioactive or non-radioactive. Then thinking about the construction and the dismantling phase, that's going to involve new materials, whether that's mining those materials, processing them, or the manufacturing requirements to produce the equipment that's needed to carry out the dismantling and demolition. And finally, if we leave sites in a long care and maintenance phase, then there will be energy costs associated with that. We all know that if we turn the power off to a building, it's at that point that it starts to disintegrate more quickly. So in order to keep facilities safe over time, we're going to have ongoing energy costs, and we could look at ways in which we could make those carbon neutral. So how can we actually look at reducing our carbon footprint at the moment in decommissioning? With the older facilities, we've probably got more challenges because we didn't think about decommissioning and how we would do it at the time they were being built. With the modern, on the new build facilities, decommissioning is being thought out at the design stage, so it's a really good opportunity to think about how are we going to reduce our carbon footprint when we take them apart. So what are the options have we got at the moment? A lot of it is about thinking about how can we reduce the energy costs of what we're doing. How can we optimize things like our transport routes, the loads we carry, how far they have to go. And we've got the tools available at the moment to do this. It's really very much part and integrated with all our other environmental controls. We might be thinking about, should we be setting CO2 budgets in much the same way that we set dose budgets for tasks. We can use our best available technique, BAT assessments, where we're looking at what's the least environmental impact that we can make, or what's the best technique we can use to benefit the environment, and we should be including the CO2 generation in that as well. Similarly, all our decommissioning sites are required to have an environmental impact assessment, And it's very much part and parcel of that to consider the potential for carbon production. And lastly, thinking about our waste management plans and the waste routes we choose for materials. If there's a choice between incineration or long-term storage, then perhaps we should be considering the carbon impact in that mix as well in making that decision. One of the ways we look at how to minimise our impact on the environment for waste, and decommissioning is all about waste, is the use of the waste hierarchy. And I think that has a lot of useful information in terms of thinking about keeping our carbon level reduction down as well. So can we prevent waste being generated in the first place? So that's going back to the design stage and looking at how we can do that. But then we've got, can we reuse materials? And we can be thinking about, can we reuse materials in the decommissioning process? Can tools and equipment be used for more than one task in your decommissioning? Can we then ensure that they get reused outside of the site, whether it's on other nuclear sites or in other industries? Then we've got the recycling option. I mean, this is a great one for things like building materials. Coming down, we're starting to look at some of the other things like trying to recover energy from materials, and also looking at things like the final disposal option, landfill or incineration, without being able to get any energy recovery. So what I want to do now is to talk about some examples from decommissioning the Consort Research Reactor. So these can be real life examples, albeit for a small facility, but I think there's some useful lessons that come out of this that could apply across the industry. So the Consort Research Reactor was operated by Imperial College from 1965 through to 2012, when the decision was taken to shut down the reactor at the end of the year. Following that, we went through 8 years of essentially turning that facility into an empty site, which is the sand pit you can see on the right-hand picture there. During that time, we spent a couple of years preparing for and removing the fuel. Then some time to get our decommissioning safety case in place, and that was in place by the end of 2015. We then spent 3 years removing intermediate level waste from the reactor facility before moving on to cutting up the concrete bioshield and then dismantling the buildings, and finally taking up the base slabs to leave what we've got there now. So during this process, there were some tasks that we carried out where we were able to apply some of that waste hierarchy in terms of reusing materials. And the first one I want to talk to you about is the core support structure. That's the structure you can see being lifted out of the reactor tank in the middle picture. That structure is about 2 meters high, and at the bottom of it you can see a plate with some holes in, and that is where the fuel for the reactor sat. So that plate's largely aluminium, but also some steel components. So that was quite active, and something that we've realized that we couldn't dismantle without some shielding. And we had a choice. Should we try and dismantle that inside the reactor tank, maybe put some shielding over the top and remote tools into the tank, or should we try and do it outside? As you can see, that reactor tank's really quite small in terms of the diameter, so we were very limited by space and access to actually try and do any dismantling within the tank. And there was also the issue that we could produce debris that would then mean that we had to deal with contaminated or more contaminated water at the end of the process. So we decided that we wanted to dismantle that outside of the reactor tank. And this is where we were able to use or reuse a lot of materials that we already had present on site. So the top picture on the right, that shows a shielded cell that we built on site using concrete blocks and lead bricks that we had already got available. And And these had come from experiments around the site that had already been dismantled. Associated with that is we needed a system of being able to see what we were doing. So that was using CCTV and display screens. And at the bottom picture, you can see where the operators were using a display screen to see what was going on inside that cell. We were able to reuse some other equipment as well, like cropping tools that we'd used at earlier stages of the decommissioning. We considered getting some second-hand master slave manipulators from another nuclear site. In the end, we came down to getting new ones, and that was largely to do with there was a small amount of contamination on the older MSMs, and also there was a question of whether they would be reliable for the job, and the issue of then having taken responsibility for them, of then disposing of more radioactive material. So we bought new MSMs for that part of the project, and additionally there was a frame built for those to sit on, and a work surface, a table that were fitted inside that cell, which the dismantling took place on. We were able afterwards to actually sell on the MSMs within the industry to another site, so it was good to find a new home for those. So that was really an example of where we could reuse materials on site, and some of them from previous tasks in the decommissioning. The second example I've got from the site is, like many research facilities that work with radiation, we had a lot of lead bricks of various shapes and sizes that had been used for shielding. In the end, it turned out we had about 42 tons of this material. Lead is a material that's very widely recycled, and we certainly wanted to make use of that option if we couldn't find a reuse option for the lead. The challenge here was to ensure that when the lead went back into the industry or to a use off for recycling, that we could say for sure that it was clean. So some of our lead bricks had been painted, and so what we didn't know is whether there was potentially any alpha contamination under the paint, because paint has been used in the past on some sites to fix contamination. Some of our lead bricks we expected would have some contamination, and some would have some activation. So every single brick had to be monitored. The ones that contained paint, the paint had to be removed first before the monitoring was carried out. So we went through this process, and cleaned any lead we could clean. And at the end of that process, I'm very happy to say that the majority of that lead we were actually able to sell on for reuse within the industry. So I actually went to a company who gathers orphan sources and then puts those together in packages to send up to storage at Sellafield. And what they needed to build was some shielded cells to store sources in at their site, and they were very happy to take the lead bricks off our hands. One thing I will say is, if you do process all your lead bricks, don't leave them outside wrapped in cling film, because they then develop a layer of lead oxide on the surface that then gives you another issue that you have to clean up before you can send them off. So that was some learning experience from our site. So what are the advantages of recycling lead? So I've looked up some statistics. So if you're going to produce, and this is for 100,000 tons of lead, if you use the primary production of lead, so that was from the delivered ore and concentrate, then it's something like 1,000 terajoules of energy to produce the lead. If you go for secondary production, basically recycling from scrap lead, you're down at 12.9. So it's a massive, massive saving to be able to reuse scrap lead. And that energy saving, obviously as well, can be linked to the carbon footprint of the primary and secondary productions. And again, you can see there's a massive reduction in carbon produced by going down that recycling route. So it's absolutely worth doing that. Another thing that we found on the site was balancing public perception against what was seen as the best environmental practice, or you know, best available technique. And one of the things we found was, particularly for some of our concrete blocks, these were essentially clean, but there was a concern over public perception that these had been sat next to a reactor for many years, and if we were to recycle those, crush them up, maybe have them used as hardcore and for roads or something, there might be a public outcry or concern over that. And we were really given a steer, partly from the regulators, to use registered landfill as a means of disposing of those concrete blocks. I think over the period of the 8 years, the feeling was starting to come round to more, actually probably we should have tried harder to go down the recycling route for those. And I think this is a lesson that we need to take forward, because there are public perception issues within nuclear, and we do need to look at how we balance those against achieving our net zero targets. So the next example I've got, this is graphite. It's a material that is very familiar to people with from reactors in the UK. The graphite around the consort reactor was not part of the reactor core. It was actually sat outside of the reactor tank, and it provided a neutron moderation for various experimental facilities. And a lot of it was sort of sat within the bioshield. So when it came to looking at how to dispose of that graphite, a lot of that came down to what the activation of the graphite was. So there was a sampling program to analyse the graphite and to work out what waste categories we could put that in. And we got the whole range from out of scope through low level waste, very low level waste, up to one block that hit the intermediate level waste category. And that was actually due to tritium. Most of that material, it was possible to send it to landfill, again registered landfill, and one advantage of that is we weren't trying to incinerate the carbon, which again is an immediate source of CO2. The one block that contained the tritium, that we did decide to incinerate, and that raised its own issues in that we actually had to break up this this graphite block into small enough pieces to incinerate, and that turned out to be actually much harder than we thought. There had been concerns when we were talking about this project that all those graphite blocks, they've been irradiated, they might break up when we start to move them. Actually, we had the opposite problem. It was really hard trying to break up this piece of graphite. Hitting it with a hammer did absolutely no good at all. It just bounced straight off. So we ended up essentially having to saw it up in a small containment system, ventilated containment, to size reduce it that way. That then went off for incineration. So we know from the facilities in the UK that we've got a big challenge to deal with the graphite associated with those reactors. So there's something like 70 tons of graphite in the Magnox and the AGR facilities, and worldwide some 230,000 tons. Two basic options really. We can either take basically non-conditioned graphite and dispose of it directly in waste packages, into deep geographical repositories, for example, or we can look at processing it further through incineration or calcination. But even then, we're still left with additional wastes, and taking that route, we're generating more carbon dioxide. There's a number of other issues as well associated with that, so that's a big challenge for the industry. So to conclude, the standard practice of taking decommissioning into consideration in the design phase is one of the ways that we can drive down the energy costs associated with, and the associated carbon footprint with the decommissioning process. At the current time, minimising our transport costs, the amount of transport associated with the decommissioning, is what will really help. So can we do things like use our building rubble on site to fill in voids? Can we find a really local recycling facility for that? And finally, if we can reuse equipment and materials that we've got on site for multiple decommissioning tasks or equipment that's already there, that's also really helpful. And on a larger site, that's going to rely on having good asset management. Thank you for your attention, and take any questions.
That's brilliant. Thank you very much, Heather, for that. It's been quite an enlightening presentation in terms of, you know, what we consider the back end of the industry and how it has an important role to play in terms of CO2 reductions and targets. Can I pick up on that point? It's quite fascinating that concept of setting CO2 budgets within your planning, because I take it as part of the decommissioning process you went through, it was implicitly done from a CO2 point of view rather than explicitly being done in terms of setting a budget for each of those processes.
Yeah, so definitely in our case, it was implicitly done. A lot of the planning for this was done some years ago, and we were thinking about the environmental requirements and how we would get our best available techniques. And as I said, that reasonably well parallels the approach to reducing your carbon as well. So yeah, implicitly rather than explicitly.
It's very interesting, because you could argue, perhaps looking ahead, that should be made explicit. How you quantify that would be interesting, you know, coming up a methodology for that. Just got me then thinking of, if you take a plant or a facility, you could do a calculation on how much carbon is locked up in that plant and facility, and how best to take it apart by reducing you know, the emissions from that plant bit by bit.
Yes, I think one of the things that will be very helpful going forward is to have an understanding for all these different processes, like if you crush up your concrete to make road fill, what's the carbon cost of that? And then you can work out, well, we've got this much concrete, so it's going to be this much carbon. So building up that database of information about what are the carbon costs of different activities will really help with that kind of planning.
Absolutely, because it got me thinking about yesterday's presentation, which Estelle did on ESG, environment, social governance. So you could sort of build CO2 budgets and how much carbon's locked up in these facilities as part of that piece, to make it more real rather than just a marketing piece, if that makes sense. Is put some, you know, that was one of the challenges put in to the discussion yesterday.
Yeah, and I think when you've got an activity like decommissioning, you can actually provide, it is much easier, I think, to make things real in terms of the carbon reduction, because you can get this information, you can set these targets, and then you can show what you've done and what you've achieved. I mean, at the moment, we spend a lot of time looking at what's our balance of recycling against sort of disposal by landfill, and trying to optimize that. So it's adding in the carbon as well.
No, it's very interesting. I mean, it's all the rage, isn't it, at the moment in your homes, the whole idea of upcycling, repurposing.
Yeah.
And why not? Is that we should be thinking about that for our plants and our facilities. And the thought, which then comes onto public's perception being a barrier to recycling the concrete blocks. That's quite fascinating, actually. I would have thought the public would have been all up for recycling concrete if you've obviously checked there isn't any, it's not active or contaminated.
Yes, I think from that, the concerns a lot of the concerns arose from one of the other licensed sites where they'd had an unfortunate incident where they had taken some material. It was below all the required limits in terms of being free release for use elsewhere. It had been used in a road in one of the local towns. This had been got hold of, I think, by the press and got out to the public, and then concerns were raised, and actually they end up taking that section of road up again. Good God. And that is the last thing we wanted to happen, and that bad publicity to go with it. But I think the communication going forward is really important, and as we were talking about communicating risk to the public, how can we do that best? How can we identify the way to communicate what the best option is overall?
Absolutely, and if that risk piece takes into consideration the carbon piece with it, in terms of what the reduction is by recycling, then that surely should help with the public perception, and remove that as a barrier to doing what generally should be the right thing, really. Yeah. So hopefully that's the way forward. Yes. No, there's some fascinating things happening. And finally, I was pleased to hear that the lead that was sold on, you got some money for it. That's fantastic. I thought you were going to say the local church bought it to line their roof. Oh no, and yes, though we got some money for it, sadly most of that was used up in cleaning it up after we'd left it outside in the rain. So, cling film on it. Yes. The perfect environment for generating lead oxide. Brilliant. Thank you very much for that, Heather. That's been a fascinating discussion, actually. Thank you very much. Yeah, thank you for the opportunity to speak.